Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 27. This is the second last day for the February daily LeetCode challenge. We are just one day away from completing this particular month's all the challenges. Okay. And again, today it's a very good question. Like let me just give you a summary of what I've seen till now. From the last few days, we were seeing questions which were revolving around the topic of prefix sum. Okay. We have seen two Fang level interview questions also in the last 2 days. And yeah, like the series is going on a very good level now. Okay. Now finally we are entering into the topic of DP. Okay. So this question is on the topic of DP. It's a very nice question. See, like I felt really happy after solving this because see the acceptance rate. It's around 55%, which is basically like it's typically the acceptance rate for a hard range question. Okay, whenever you see hard range question in lead code, you will see this kind of acceptance rate for it. And this being a medium question has this kind of acceptance rate. This is a very nice question. I will tell you. Like, see, point is, it's not just about solving this. It's also about how to optimize it further. So today I will be showing you three solutions. Basically, remember all the solutions are accepting and all of the solutions are able to clear all the test cases. Still, I will show you how I'm getting, like, say, I will be showing all the logic building steps, how I'm getting the intuition that okay, here we can optimize, and then I'm optimizing there, and then we are like doing it further. Okay, I will be showing you three such steps. So I will be showing three solutions in total in this video. And yeah, this is a very nice question. I'm sure that the first solution would have already guessed, but yeah, the next two solutions we will just have to build on the intuitions that we have and based on the outcome of this, and then we will be going further. Okay, so it's a very nice question, and after this video, you will be having a very good grasp. You are going to grasp a total like thorough solution for this question. Okay, because now you will be knowing all the combinations that could be run in this kind of scenarios, right? Let us quickly begin. See, my expectation is that you would have, see, first of all, this is among the first 1,000 questions of LeetCode, so they are called the golden questions. Let me repeat this thing because this question deserves that praise. Okay, now I am assuming that you would have already gone through the question. If you have not, just let me highlight the important points. Then you can pause the video, take the question link from the description, and then see it. Okay, then you can come back to the video. Okay? So what I think is the question is revolving around the topic of Fibonacci series. Okay, so what is the Fibonacci series? It's something like, see, you are adding two numbers. Okay, let me just quickly show you how it works. Let us say you're starting with one. Okay, so one you have, then you have two. Let's say always remember the first two numbers you will have to choose that. Okay, remember these numbers can be anything. The first two numbers can be anything. Okay, the numbers coming after this is something that is going to be see, first two numbers determine what all numbers will come after that. Okay, in this case I have taken 1 and 2 for example. So the sum of these two, 1 and 2, is 3, so I will write 3 here. Similarly, the sum of the next two numbers is 5 now, so I will write 5 here. Similarly, the sum of last two numbers is 8 now, so I will write 8 here, and so on. So the idea here is that you will always add last two numbers and you will generate the next number. So idea is the whole series is getting generated based on the first two numbers. So in this question also, these first two numbers is going to play a very important role for us to determine the whole sequence. Okay, so if you see the question, actually what they're saying is you are basically given straightly increasing array. Okay, if you see the constraint of this array, each element in this is going to be in the range of 10 power 9, which is very very huge number, by the way. Okay, it's going to be in the range of 10 power 9. Okay, and the length of the array is going to be around 1,000. Okay, now what they're saying is you will have to find, see, as I mentioned, the Fibonacci series depends on the first two, okay, values of your sequence. Okay, it's like depends on which first two values are taking, so that the rest of the values that are coming will depend on that. Now they are saying that the first two values, they are not giving anything like that. Okay, they are saying you can take any value from these things. Okay, they have just given that this array is a strictly increasing one. You can start from any pair, okay, as such, and then you have to return the longest possible, that is the length of the longest possible Fibonacci series. Okay, remember the Fibonacci series, they are saying in terms of subsequence. Okay, they are saying the longest subsequence, that is a Fibonacci like series. Okay, they are saying that, so you have to return the length for that. So in this case, you see they are saying this. Okay, if you see, it's like a subsequence. Okay, what is the meaning of subsequence? Subsequence means they need not be adjacent. Okay, they need not be in a sub array. They can be apart from each other, they need not be adjacent to each other. In this case, if you see 1, 2, and 3, if you see, okay, they are together, and then after that 5 and 8. Okay, 5 and 8, if you see, they are not connected to 1, 2, and 3. 1, 2, and 3 are here, 5 and 8 are here. So that's what is the meaning of a subsequence in this case. Okay, so that's why I'm not going through the whole question, but with the example one itself I'm trying to explain the whole question. Okay, they are talking about you'll have to find the longest subsequence that is following the properties of a Fibonacci like sequence, Fibonacci like series. Okay, so they have given the example of this. So among all of these, you can start with any pair and then you can keep building it, and at last you'll have to return the longest subsequence length. Okay, that is following the Fibonacci properties. Okay, that is the final question for us. Okay, you can go through example 1 and 2, they are really good ones, and then let us quickly jump into what we are doing. Okay, so the first thing is we'll take the benefit of what we are already given. So in this case, it's a strictly increasing one. Okay, we will take the advantage of this now. So see, as I mentioned, always the series, like the elements that are going to be part of our series, depends on the first two elements. Okay, it depends on which two elements we are choosing. So what we'll do is we'll take every pair possible among this, and we will try to generate the series, and the longest one among them will be our answer. Okay, let us quickly implement that. Obviously this is not a very optimal solution, but we will like try to optimize it here based on our observations of this solution. Okay, let us quickly do it. What I'm doing, see, I'm first of all, see, I'm capturing it in a set. Why I'm doing this set? See, if I capture, what will happen is it will be easier for me to check. For example, see, I have taken a pair. When I add them, a number will come. I have to see whether this number is already part of my given input or not. For seeing that, it will be very easy if I have this in a set. Okay, that's what I'm doing. I'm capturing all the elements in a set. I'm calling it as a nums. Right now, I'm capturing the length of the input. Then I'm declaring my answer. This is going to be my final answer. Right. Then I'm starting the for loops. Okay, this will be till n minus 2, and this will be from I plus 1 till n. Okay, as simple as that. Why I'm taking this n minus 2? See, the reason is the Fibonacci series has to be at least of length 3, right? So if it is not of length 3, then it doesn't make a sequence at all. Okay, in this case also, this is edge case basically for this question. Always the sequence that you're finding has to be at least 3 or greater than 3. Okay, if it is less than 3, then you will have to return 0 as your answer. So the answer is going to be either 0 or greater than or equal to 3. Okay, that's what the answer range is going to be. For that reason, if there are no 3 elements not possible at the end, that's why I'm taking the starting element like this. Okay, so I is going to be the starting element, that I is going to be the index of the starting element, j is going to be the index of the second element, and then the sum of these two, okay, AR5 plus AR of j is going to be the third element. We'll have to just see whether this sum exists in our input or not. Okay, so that's what I'm doing. So see, I'm capturing a and b. A and b are going to present the first two elements. Okay, now I'm just calculating this value, which is 2 initially. Now if a plus b in nums, what I'm doing, just store the sum in temp, then let's start shifting. Okay, b will go to a and temp will go to b. Okay, this is how I'm shifting it basically. Okay, now same thing again, a and b will be checked, and if it is in nums, again the same thing will be followed, and every step we are incrementing the length by 1. Okay, at last, once we come out of this particular while loop, what we are doing is we are trying to record the length that we have got in our answer. Okay, this is a very simple solution. At last, if you see what I'm doing, if the answer is greater than 2, okay, in that case the answer is going to be that number. Otherwise, the answer is going to be 0 if it is not greater than 2. Okay, let me quickly run this and show it to you. This works, and this, yeah, you can segment this solution also, it works. Okay, but let us talk about space and time complexity. Space wise, it is O of n. Time wise, it is going to be O of n square into log n by c. O of n square because it is, there are two for loops, and log n because see, this is a while loop, right? This while loop is basically taking log n time, right? So yep. Now let us see how to optimize further. Okay, if I can show you the output, see, this time what I've done is I've added some print statements in the same code. I've added some print statements so that we can visualize what is actually happening. Okay, so if you see, this is how the things are happening. So for the first pair, that is 1 and 2, we are able to proceed further till 8. Okay, similarly for the second pair, 1 and 3, we are able to proceed till 7 and so on. But if you see, a major drawback of this is, see, for example, 1 and 2 we have taken. Okay, after that these all pairs are coming, but if you see 2 and 3, it's again getting explored. See, here 2 and 3 already explored, but if you go here, okay, if you see 2 and 3 is again getting explored here. Okay, see, 2 and 3 we have already explored till 8, but here again we are exploring 2 and 3. Okay, this is actually a wastage of our computation. Okay, so we are basically recomputing the stuff, which is not a good idea. Okay, so we'll have to break this into sub problems in such a way that we do not solve the sub problems again and again. Okay, this tells us to the idea that this leads us to the idea that we can solve it using DP. What is the idea of DP? Idea of DP is that we can break the whole problem into sub problems, where the sub problems are of repeating nature. Okay, once the sub problem is solved, that result can be used again and again, so that we avoid solving the same problem again and again. Okay, that is the basic idea. I hope you are understanding what I'm saying. See, here 1 and 2 you are taking as your first pair, and then you are continuing further. But what is happening is, here for example 2 and 3 is there, you are extending 2 and 3 further, and you're going till 8. Okay, now what is happening, 2 and 3 you have already explored till 8. Okay, but here you are again exploring 2 and 3. Okay, so the idea, this is a wastage of resource, because see, this one you have already got. Okay, now if you are doing this thing, it's a wastage of resource. That's what I'm trying to tell you, right? Same thing is happening multiple times. See here, for example, 3 and 4 we already explored. Again 3 and 4 will be coming somewhere here. Okay, yes, that's what. So this is actually a wastage of resource. We'll try to avoid this. To avoid that, what we are going to do is, see this part. What I will now do is, I will be storing all the pairs that I've seen. Okay, so see, this code remains exactly same, but there is only extra thing, which is pair seen. So whichever pairs I have seen, okay, as the Fibonacci series depends on the first two values that we are taking. For that reason, I'm going to call that as a pair. Okay, so all the pairs from which we are starting, I'm like, from which we are like proceeding further, we will be recording them here. Okay, so in this case, if you see, what all will be recording in this case, if you see, for example, see, 1 and 2 will be recorded, 2 2 and 3 will be recorded because they are also explored. Similarly 3 and 5 will be recorded. Okay, and then 5 and 8. So the idea here is, we should not explore them again. So in this case 2 and 3 will not be explored again, this part will be gone. Okay, similarly 3 and 5 will not be explored, this part will be gone, and so on. Similarly 5 and 8, okay, this part will not be coming again. So that is the basic idea. Let's see how we are implementing it. So this is the code for that. See what we are doing in this case. If you see, okay, let me show this part. So in the while loop, inside the while loop, what I'm doing is, once I have the pair, what I'm doing is, see, see directly A and B I'm not inserting in the pair, okay, because see obviously anything of length 2 is not of any use to us. If it is greater than length only, then it will be of use to us, okay. That's why in the while loop what I'm doing is whenever a pair is coming and we know that A plus B is nums, in that case what I'm doing in that step I'm adding A plus B as a, see this pair as a tuple is inserted in our pair scene, okay. Now in the starting condition, so whenever a new pair is coming we are just checking if the tuple, okay, of this pair is already then our pair scene already there in our set, then we should not continue further, okay. That's mean go to the next iteration, okay. So the rest of the code will not be executed in that case, right. That's why whichever pairs we already explored, that we are putting it in the set, and this ensures that the pair is not explored again, okay. That is the first optimization that we are doing, okay. Now, so yep, that's it, going to the first optimization. I will show the output for this, but before that, let me show the second optimization also. See, the idea here is, for example, like again, let me go back here. See, in this case, what is happening in the first pair, that is 1 and 2 itself, we are getting a sequence of length 5, okay, of length 5. So the idea here is, can you quickly tell me? See, already we are getting answer of 5. So can you quickly tell me till which extent the starting, see, A and B are there, right? The pair is coming from first letter and second letter, right? Now, if my first letter starts from here, okay, see, just take an example. See, we have already got our answer of length 5, right? Now let us say, I see this answer is coming when I'm taking 1 and 2, okay. 1 and 2 is the pair. Now let us say my first I'm at 5, I'm going to pair with 6, okay. So can this is it, uh, if I explore further with this pair, is it going to do any better to our answer? See the case, 5 and 6 is there, even if the rest of the characters are forming a sequence, still this will be going up to length 4 only. Are you getting my point? So there is no point in exploring this further. Are you getting my point? See, even let us say I'm at 4 and 5, even if this works, still I will be getting a length 5 only, which is already there with me. So if something has a potential to exceed 5, only then I should be exploring those pairs. That is the basic idea which I'm following, right? So if you see, I'm adding an extra condition here, so I'm going to add now this condition, okay. So if I so now see, answer will be updating at every step, right? See, in this case answer is getting updated every step. So the idea here is, if we have already seen an answer, we should avoid certain pairs now, okay, because we know that, see, for example, answer is 5, then if I start the first letter here, okay, first number here, and the second number, let us say 5, okay, 4 and 5 I'm taking, obviously even the rest of the numbers follow in the same sequence, still it is going to have length 5 only, which is of no use to me, because I need a number which is greater than 5. Only that will be helpful to me, right? So for that reason, what I'm doing is, if I is greater than equal to n minus answer, then you should not continue further, okay. Then you should not continue further, that is, skip the rest of the code and go to the next iteration, okay. This will save us a lot of recalculations, because see, the answer that is going to come is obviously going to be less than or equal to our existing answer, which is of no use to us, okay. That's why we are skipping all these i's, okay. Once I goes beyond that, we can simply continue further, or you can say simply break further, okay. Maybe break will be the right word here, okay. I did not write break statement here, you should have written break here, okay, because after that I will be going on exceeding, right? So what you can do is, you can simply break out of it, okay, as simple as that, right? Yeah. So here I've added the first break statement, and here see, y is going to the starting word, similarly j is going to be the second word. So here n minus 1 is there, n minus 1, so here I've written n minus 1 plus 1, okay. Just I'm adding a plus 1 there, because j is just after I, okay, as simple as that. Just think of it in that way, okay. And here I'm breaking it. Even this code I've already segmented, so this should also work. Previously I've written continue statement, but yeah, like that was a mistake. It should have been a break statement. You can write break statement here, and that should also work, okay. So after doing this optimizations, if I can show you how it works, see, this is going to be the final output, okay. After applying these two optimizations, see this case, this was our previous output at last, and see how many cases are coming now, okay. See how many cases, this many cases are coming now, as you can see, this many cases, how many cases are coming now, how much exploration we are doing. But now we are only doing this much exploration. See, with 1 and 2 itself we have got that much, then 1 and 3 is coming this much, and then 1 and 4 till 2 and 4. After that we are not doing, because we have already got answer of length 5. So if there is no possibility of a answer greater than length 5, we should not explore further, okay. That is all. And these are the various pairs that we are caching, so that we do not explore them again, okay, as simple as that, okay. So that's, if you see, we are only now doing this much exploration, okay. You can basically segment this kind of, I will give you this code, I will segment and give you this code. This will also work, and you can try the same. So we have done 3 optimizations. I can again repeat what we have done. See, in the first case we are doing a basic solution, we are just focusing on the starting pairs, okay. So we are trying to combine every kind of pair possible, okay, and then we are proceeding further, okay. That is the first idea. But in this, the disadvantages, for example, see, if you start with 1 and 2, you are already getting 2 and 3 as a pair also, okay. So already exploring 2 and 3 also, then similarly you are already exploring 3 and 5 also. But what is happening, let's say this case of 2 and 3, it is again coming here, so 2 and 3 again getting explored, which is not a right idea at all, okay, because this is a wastage of your calculation. See, even if it goes till the end, still you will see you will get an answer less than the existing one, right? So it's of no use, okay. That is the reason why what we have done is, we are now storing those pairs in a set, okay. So whenever the set is coming, we will not execute it further, okay, simple as that. And then the second option that we can do is, see, once we got an answer, okay, let us say the answer is of length 5, then our starting point, let us say if the first number is here, the second number is here. Okay, so if let's say the first number is here, so even if all the numbers after that form the same sequence in a Fibonacci way, still the answer is going to be 5 only. Okay, we have already got answer 5, so there is no need to explore this much further. Okay, so that is the reason why what I'm doing is, if I is greater than n minus 1, then you can simply break. Similarly, if j is greater than n minus 1 plus 1, so you can simply break. Okay, so yep, now if you see what is happening this way, what we're trying to ensure is now every pair is explored only once. Okay, so previously what were happening is time complexity was n square into log n, but now that log n will be removed. Okay, why? Because every pair will be explored only once and only once. Okay, we will not explore them further. Okay, as simple as that. So that is the reason why now the time complexity is getting reduced to O of n square. But yeah, because of this much stuff, we are also increasing space complexity to O of n square. Previously it was O of n, now it is O of n square. But because of that, we are able to reduce the time complexity from O of n square log n to O of n square. So yeah, fun, that was all for this particular video. I've shown you 3 solutions. Okay, in the first solution, we are doing the simple stuff. In the second solution, what we did is we tried to save the page that we already explored so that we do not explore them again through this. In the third optimization, what I've done is I have now included these two if conditions. Okay, now what are these if conditions? The idea here is, once we have a length, okay, once we have an answer, what we can do is we will avoid exploring those kind of cases where we know the answer can never exceed the existing answer. Okay, that is the reason why we are doing adding this if kind of statements. Okay, yep. So yeah, friend, that was all for this video. It was in the final solution that I'm showing you. It is O of n square time complexity and O of n square space complexity. Okay, why O of n square space complexity? Because we are studying every kind of pair. Okay, and how many pairs total can be formed? It is going to be n. Obviously, like in rough way, if we see, it is going to n into n, right? As simple as that. Because see, let's say there are two numbers. First number can be chosen n way. The second number can be chosen in n minus 1 way. So yeah, n into n minus 1 is going to be your answer. But again, it is around O of n square. That's why I'm saying the space complexity is also going to O of n square. But again, in my solution, if you see the way I'm doing it, see, for every a and b, we are not storing them in a pair. Only if the length exceeds 2, only then we are storing them in a pair. Okay, that's why if you see the final output, okay, this is going to be a final output. If you see, only this much pair we are saving. Okay, we are not storing like n square pairs. Okay, but just to give you upper limit of what we are doing, that's the reason why I'm saying it is around O of n square space complexity and around O of n square time complexity. So yeah, that was all for this video. And yep, I really enjoyed this question. Let me know your thoughts. But yeah, I like my aim is, this solutions will be there in the comment section. My aim is to like cover whatever is there in my mind, so that when you see this kind of solutions, and like when you see, obviously you can add some print statements like I have done. Okay, I've added those print statements like this kind of stuff, and yeah, this kind of stuff, and yeah, I'm finally printing them so that this will help you understand what is happening. But yeah, in the final solution, you can remove them. Okay, as simple as that. So yeah, friend, that was all for this video. And if you like my efforts, please do subscribe to the channel. This really takes a lot of time and effort to build this kind of videos. And always my aim is to show you something different, to show you something better, to show you something what others are not thinking. Okay, where others are not thinking in that direction. Okay. So yeah, friend, that was all for this video. Please subscribe to the channel and see you tomorrow. This was my 128th day, and assuming we'll go further to a long extent. Right. See you tomorrow.